Hey guys, it's Miss Mirasola coming at you live, trying to explain voltaic cells or batteries, how batteries work. So batteries work by a process called electrochemistry. And if you take out this worksheet, I sent it to you in the email. Obviously you found it, that's how you found this link. But have this out, have it printed out, or you can draw it out, because I'm going to give you some notes to put on it, and it's going to help you with the next page. Okay? All right. So first things to start off with, we talked about an electrode. Electrodes are metal rods that are in solution. In this case, this electrode is made out of zinc, and the S means that it's a solid. And this is copper, Cu is copper, and again, S means solid. So a solid zinc bar in this solution of zinc sulfate. This is a solid copper bar in a solution of copper sulfate. Okay? And so what's going to happen is one of these electrodes is going to lose electrons to the other electrode, which is going to accept those electrons. Any electrode that is the electron donor is called your anode. So over here is your anode. And your anode is always going to be the negatively charged side because it means it has a ton of electrons. So since it has so many electrons, it's an electron donor. Donates electrons. Over here is your cathode. The cathode is the positively charged, which means it needs electrons. And since it needs electrons, it is the electron acceptor. And in this case, the electron acceptor, or the cathode, is copper. And over here, the anode, which is the electron donor, is zinc. Okay? All right, then we get into the solutions. Zinc sulfate and copper sulfate. These are both sources of more electrons if needed. Okay? So, as all of these electrons are piling up over here, we are losing the imbalance. So because there's so many positively charged ions over here, it means they're accepting electrons. But every time one goes over there, you're losing one, all right? You're losing one, losing a charge, losing a charge, losing a charge. Once you lose all your charges, then the electricity stops flowing. That's bad. So in order to keep the charges here and not lose them, every time an electron comes over, what's happening is a copper ion is breaking off from the solution and being added to there. What's happening there is this is a source of positives. So every time a negative comes over, I'm going to lose a positive, but then another positive is going to come back and just put it right back. It's going to keep the electricity flowing. Okay? So that's what a cation is. A cation are positively charged ions. And as we remember, as this zinc atom lost electrons, it made positive ions that are coming into solution. Well, now these positives are building up over here. I don't need them here, I need them here. Because if they're here, the electrons are going to stay here and just get sucked right down, and I'm not going to have any electricity flowing. I want to keep the electricity flowing that way. So I need to have my positives over here. So this is where the salt bridge comes in. The salt bridge is a porous membrane that allows cations, which are positively charged ions, to permeate and go across here. Since all of these electrons, these negatives are coming in, that's what's attracting these positives over here. So as I get an electron coming in, I'm going to get a positive, and those two things are going to be attracted to each other. All right, so cations are positively charged and they're in solution. And the anions are negatively charged, and they are in solution. So, as this copper sulfate is breaking apart, I'm adding my positives to here. The electrons are coming in and building up, building up, building up, building up. I don't want them to build up here near these positives. I want to send them back so they can keep coming. And so it goes through the salt bridge. Okay, so the salt bridge is just a very porous membrane that allows certain anions to pass through. Okay, so to go through this whole thing. In order to make electricity, you have to have electrons that keep flowing. In order to do that, you have to make sure you have a positive side and a negative side. So you add electrodes. The negative electrode is the anode. It is the electron donor. It's negative, it has plenty of electrons, it's going to donate them. The cathode is the electron acceptor. It needs plenty of electrons, so it's going to accept them. As these electrons are building up, the ions in solution from the copper sulfate are bonding on to this electrode. And I'm making it bigger and 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 bigger because I'm adding to it. I'm adding these to it, and so it's getting bigger and bigger. Over here, I'm losing everything. I'm losing it. I'm losing it, and so I'm getting smaller and smaller and smaller. So this side gets reduced. Okay, this side gets smaller. This side increases in size. It's getting much, much bigger. Okay, so eventually I'm going to run out of all of this. And once I run out of all of this, that's when a battery goes dead. There's nothing left for the chemical reaction to take place. There's nothing left to send electrons. And so that's what makes a battery dead. At the same time that this is getting smaller, because electrons are going over here, this fluid is also getting lower because it's donating all of its ions over here. So these ions, things that need electrons, are bonding with the electrons and becoming atoms. So now I'm building copper atoms onto this cathode, onto this metal rod. Okay? So the fluid is getting lower here. But over here, the metal rod is getting lower. This fluid is building up because all of these things that are breaking off and going into solution are increasing how much stuff is in that solution. So this level is rising slightly. I'm exaggerating the levels of these. And I guess to say the solutions are lowering or rising might not be the best thing. It's the copper. I'm losing copper. I'm losing copper out of the copper sulfate in this solution. And here, I'm gaining zinc in the zinc sulfate in this solution. So if you're looking at these levels, you're not going to see them rising and falling. But if you were to test them chemically, you would see there was a lot less copper in here than when it started because that copper is becoming part of the cathode. And here, you would see there's a lot more zinc in the solution because the zinc is leaving these anodes to become part of the solution. All right, I hope that helps. You can use this and to figure out that next page. I'm always here if you guys need help. Just send me an email or, just send me an email and we can set up something if you want to do FaceTime or Zoom call or Skype or whatever you want to do. But anyway, I miss you tons. This classroom is so boring without you. This is awful. Anyway, see you soon.